Looks like we're live. Hello everyone and welcome to yet another Azuzin session, but you didn't expect that shit to happen. So let's make a little bit of an announcement and officially start the stream. Hello, welcome. So let's do the usual red circle live on Twitch. And what are we doing today on Twitch a television website? That's a very important question of today. Today we're doing TypeScript computer science. That's exactly what we're doing today. I'm gonna give the link to the place where we're doing all of that. Twitch.tv/Zoding, and I'm gonna ping everyone who's interested in being pinged, and there we go. The stream has officially started. So today we're gonna continue working on Autocell, the project that we started like a couple of streams ago. Right, so you can find the source code in here. I'm gonna copy paste it in the chat. Right, for people on Twitch, and for people who's watching on YouTube, it's gonna be in the description. Right, so basically here we are experimenting with cellular automata, right, and essentially what we are trying to do, we're trying to take like a Conway's Game of Life style cellular automata, which uses like a Moore's neighborhood for, you know, computing the next state of the cell, and we're trying to generalize this kind of automata by introducing the transition table, right? So instead of like describing cellular automata with the code, with if conditions and switch cases and stuff like that, we introduced a transition table, and that way we can actually sort of describe the cellular automata without writing any actual code, like purely with the data of transition table. So, and we've already done that, right? So on one of the previous streams, so we can take a look at that. Autocell, right, I'm gonna just rebuild the entire thing just in case. We're using TypeScript for all of that, right? We're using TypeScript. And let me start the Python web server. And that's the web server that I use these days, even though for the topic of today's stream, it would be actually better to use some built-in Node.js HTTP server, right? Because we're using Node.js, so it would be sort of like on a theme of the stream, right? But I kind of got used to using Python instead, because it's just like, this is just in my muscle memory. Let's go into the local host. I suppose I need to refresh. We were doing some experiments that we'll get into a little bit later. Right, so here I suppose we just have a setup Conway's Game of Life, right? If we go into the source code, there should be current automaton. Yeah, actually it's not Conway's Game of Life, right? It's something else. So let's actually set it to Game of Life, right? And I'll have to rebuild this entire thing just in case. Right, I'll have to rebuild just in case, so I'm gonna refresh this entire thing. Hopefully it is going to be a correct thing. So with my Chromium, you never know if it cached the thing or didn't properly cache, so I have to first open the DevTools to make sure that it doesn't cache anything. And I'm gonna put some sort of a glider in here, right? I'm gonna put some sort of a glider in here, and there you go. It is a gliding, it is a sliding, right? So, and then it should be super easy to switch to a different cellular automaton. If you take a look at the definition of goal, it's literally like a JSON thing, like it's an array of objects and stuff like that, and it describes the transitions of different states, right? So we have other things in here, so let me take a look. So we have a seeds cellular automaton, right? It's a similar to Game of Life cellular automaton, but it's different. It's actually way simpler, right? If we take a look at the definitions, right, it's way simpler than Game of Life, right? So it basically expects only 2 alive neighboring cells, and it becomes alive, and if it's alive, it just becomes dead. So it's a very simple one, right? So let's actually recompile this entire thing. Alrighty, and I'm gonna refresh this entire thing, and let me see, right? So, and the cool thing about seeds is that it's sort of like, it's a region with a static noise that keeps growing, right? So one of the interesting feature of the seed cellular automaton is just like a region with a static noise, with a lot of different static noise, but it keeps growing until it consumes like everything. So that's what's cool about this specific cellular automaton, right? If we try to do that, so as you can see, like it's a region of static noise that just keeps growing and growing and growing until it just consumes everything. So it's so cool, right? So there we go, and then it consumes everything. So the entire world actually wraps around, left and right, top and bottom, right? So it's kind of infinite, but it's finite in the sense that it wraps around. Right, another interesting cellular automaton that we have is a Brian's brain. It's kind of similar to seeds, except it has 3 states, right? It has 3 states instead of 1, and the third state is basically dying. And when the cell is alive, it becomes not dead, but dying, and then on the next generation, it becomes dead, right? So that way it prevents any other new cells being born in that specific place for one step, right? So for one turn specifically. So that's basically the difference in here. And let's actually put some stuff in here. So the dying cells, I think they're denoted with a green color, or we'll see. Yeah, there we go. And it creates a lot of interesting emergent behavior, which actually died out, right? So let's actually try a different stuff in here. It creates a lot of gliders that are flying orthogonally, right? So up and down and left and right. They rarely actually fly diagonally. At least I've never seen them flying diagonally, but it creates a lot of like gliders which are orthogonal to the axis. So let's actually see. There we go. It created like one, but for some reason I cannot make it explode today. Right, it's already second attempt. The thing about Brian's brain is just it's very explosive, right? But you have to have enough stuff to make it explode. There we go. It created a bunch of gliders, right? Orthogonal. Maybe eventually they will collide with each other, but yeah. So these ones probably will collide, and maybe they will create something interesting. No, they're actually not. Usually it's super easy to make Brian's brain explode, but not today for some reason. Not today. Yeah, created a bunch of stuff. Yeah, that's pretty cool. So I should probably do some sort of autoplay, right? But I need to spend some time implementing that actually. Right, so this is a Brian's brain. So the whole point of this demonstration is that it's super easy to replace different cellular automaton. Right, automaton. They're just tables, right? They're just these sort of tables. We coded those tables manually, right? But because they are transition tables, they're very easy to essentially generate procedurally, right? We can try to generate them procedurally. And how can we generate them? Based on what we can generate them. So one of the initial ideas that I had when I started this entire project is to actually sort of train cellular automaton on image, on a pixel art image, right? Essentially take a pixel art image, take all of the unique colors, call them states of cellular automaton, then iterate through all of the pixels and look at the neighboring ones, and based on the neighboring ones, turn that into a cellular automaton, right? Maybe feed more images into that, so the cellular automaton actually sort of conceptualizes and compresses even more images into that, and then try to play that thing, right? So I sort of developed this framework that allows you to describe any cellular automaton with a Moore's neighborhood specifically, so I can turn some images into cellular automata, right, and see how they're gonna play out. We haven't tried that yet, so this is sort of like in the experimentation phase, and that's what I wanted to do today. So we found some pretty cool image that I think will work for our case, right? So let me take a look at this entire thing super quick, right? So we have this, right? I find it on Open Game Art, right? So this is a bunch of characters which I think perfect for my idea, because we have a limited amount of colors in here, and we have a very pixelated characters, but they are still readable as characters, right? So maybe the cellular automaton will actually reconstruct those things. It actually depends on how we're going to construct the cellular automaton based on these images, right? So, and one of the problems that we had is how can we read those, the pixels of these images in a browser, because all of that stuff is happening in the browser, right? And I was not happy with how web people usually do that, right? I didn't want to work with image tags and stuff like that. And because of that, we went on a tangent of actually bringing stbimage.h into a browser, right? stbimage.h, it's a rather famous in game development circles library for reading images. It's just one single header file, which allows you to parse PNGs, JPEGs, GIFs, and like a lot of stuff. It's like 8,000 lines of C code, right? And it allows you to parse pretty much anything, including even like a limited subset of Photoshop files, right? So, and what I did, I compiled this entire thing to WebAssembly, right? So we spent some time streaming and researching how to do that. That was not a particularly pleasant experience, but we managed to do that. I created a separate library called stb. I hope I can do anything. The file is so big, it made the website lag. Right, so let me go stbimage.js. So this is the library I created, right? So essentially what it does, it compiles stbimage into WebAssembly, and it creates a couple of simple bindings for JavaScript and TypeScript, so you can actually use it. So what it allows you to do is essentially load an image from URL, right? You see, it just gives you this function, which does load from URL. You provide a URL, you get a promise, and you instantly get image data. You instantly get image data without any tags, without any off-screen canvases or anything like that. What it does, it downloads the pixels of that specific image. It gives it to the WebAssembly module. WebAssembly module actually parses the PNG or JPEG, whatever you have, and turns it into image data, like in one go, without modifying DOM or like creating something off DOM or anything like that. It just does all of that in WebAssembly. Right, you can find this entire thing in here if you're interested. So it's going to be here, and I'm going to give this entire thing to YouTube people as well. So stbimage.js. So the cool thing about this library is that it's purely C library. People don't really use this library outside of C projects, but we're running this library in a browser, and this library was not designed to be run in a browser. But because of how simple that library is, it is extremely easy to make it run in a browser. Right, so essentially what I want to start with, like today's stream with, is adding this library back to the project, right? And essentially read the image and start analyzing the image and start finally trying to turn it into cellular automaton. So that's basically the plan for today's stream and the idea for today's stream. All right, so let's go ahead and just actually try to integrate this library into the project back, right? So we started actually by writing this kind of stuff within the project, then I separated it, and then I'm bringing it back. So the cool thing is that I actually made it extremely simple. So it's literally two files, right? It's a WASM file, right? So we can actually download it in here. Right, I wonder if I can just like download it. Unfortunately, I can't. This is the download button. I cannot see it. Okay, so I'm gonna keep the link. Hopefully it will allow me to download this entire thing. So this is gonna be Autocell. Maybe I'm gonna actually create a WASM folder in here. Right, there we go. And we're gonna try to download stbimage WASM, right? It's a binary file, binary WASM file that contains everything that we need. 52 kilobytes, right? 52 kilobytes. It can actually build everything. It can parse everything, all the images and stuff like that. So you can see it's a WebAssembly binary. We're gonna keep it in here. So the second one is usually the JavaScript file, right? So this is JS file. But it's compiled from the TypeScript file. So, and since our project is a TypeScript file, I think I'm going to download the TypeScript one. Right, the TypeScript file is extremely simple. It's, I think, yeah, it's 50 lines of code, literally. What it does, it just like asynchronously loads the WASM file that you provided in here, right, and just makes a simple wrapper for the C function, so you don't have to do the manual memory management, right? Because it's a C library, you're supposed to do some manual memory management. This function just does that for you, so you don't have to worry about this kind of stuff. And it doesn't leak any memory, by the way, right? So it cleans up everything after itself. All right, so I'm gonna use that, right, not the JavaScript one, because for TypeScript project it just makes more sense, in my opinion, right? I think, in my opinion, it does make more sense. I'm going to download it in here and I'm going to put it in here. All right, so just a second. I forgot. I need to put yes in here. All right. Alrighty. So let me try to recompile everything. As far as I know, if I do TSC, it just like looks for all of the TypeScript files within the project, right? And it compiles all of them, so it will compile the JS one here as well, right? Hopefully, for some reason, when I'm streaming, the TypeScript compiler is rather slow. Right, okay, so to make it actually work, I'll probably have to include the stb image.js in here as well, right? So we'll have to include this entire stuff, and let's actually start. I think I already have the web server running, right? Do I have web server running? I think I do. So let me confirm that we're actually downloading the WASM file, right? Do we download the WASM file? Yeah, we do. Okay, so it actually downloads the WASM file, so everything is okay. So the thing, that thing should be able to just like download the image, right? So let's go ahead and see how I can do that. So I'm gonna go to the index, right, and so where is the entry point? So this is the entry point. So here we're just like searching for some nodes in a DOM, doesn't really matter. So what I'm gonna do, stbi. Can you, yes, stbi load from URL. In our case, we probably want to do URL. So I'm going to be loading cute people. Right, loading cute people. And specifically, we're going to be loading this image. Right. So, and since it returns the promise, right, if we take a look, it returns the promise, we have to await this entire thing. And we're gonna assign this entire thing to cute, right? And that entire thing is actually literally an image data. It's already an image data that you can just already use. And here you can just slap that image data, put image data cute at 0, 0. So we can just like render it on the canvas, and that theoretically should work. But we have to, of course, recompile this entire thing just in case. We have to recompile all of that. Are you gonna recompile? Okay, so it didn't compile because this entire function is not asynchronous, right? Right, let's make it async. There we go. So this function is async now. Let's go. So is it recompiling? Okay, so it seems to be recompiling. And it put it on the canvas. Look at that. So, right, so we managed to load that. So, but what's cooler is that since it's an image data, we should be able to get the data, which is essentially the pixels, right? So we can literally just do console log and like this. And that means we should be able to analyze the pixels, right? We should be able to analyze the pixels. So let me quickly do the watch mode, right? So I'm gonna actually go in here, all right, and it's gonna be node bin tsc watch. So that means it will keep recompiling like as I edit things, right? So that's pretty poggers, I believe so. Right, so it should recompile all of that. And as you can see, here is the pixels of this entire stuff. So the problem is that pixels is a clamped uint array, right? So that means it's actually multiple of 4, right? It should be multiple of 4. If I take the length of this entire thing, right? So it's 12288. 12288, and then if I take the mod of this entire thing, it's 0, so it's divisible by 4, right? So we need to turn it into uint32 array somehow. The last time I tried to do that, I think it didn't really work the way I expected it to work, right? If I literally just rub this entire thing like so, I think it's not gonna divide the size by 2. I don't think it's going to work the way I think it will work, right? So let me actually do something like this. Yeah, so as you can see, it stayed the same. So if it would actually turn it into like uint array, it would basically divide it by 4, but I don't really know what's up with that. So we got this up. Thank you so much, Kiyagotka. for tier 1 subscription with the message, now I can backseat even in subscribe only mode. Okay, sure. People are like literally paying money to backseat me. That's very interesting. Is it that enjoyable to backseat me? I don't understand. So what's appealing in backseating me? I don't understand. Because when I watch somebody's streams, which I rarely do actually these days because Twitch is unbearable, right? When I watch somebody's streams, like I don't have a single urge to backseat anyone. It's just like I don't feel like doing that. I'm more interested in watching how the streamer approaches the problem. Even if I see how I could solve that, I'm still curious about the way they're solving it, right? So I don't really understand the appeal, but people seem to like that. Jiang, what's up? All right, so I don't really know how to convert this thing into uint32 array, because I remember if I just had something like this, right? Because I remember giving uint8 array to uint32 array, and it would actually cut it in half, right? So what if I try to do something like this? Will that work? No, it didn't work actually. So I think it has to be an array buffer, right? So if I take a look, array buffer, right? Can I construct an array buffer out of this thing? Is that something I can do? Looks like this is something I can do, but I'm not 100% sure. I think I need to enable the fly check mode. Okay, so it complains about cute. So what's up with that? Argument is not assignable to a type number. Oh, okay, this one is interesting. So this is an array buffer. So it simply cannot do that. So array buffer, I suppose, expects a number. All right, we can give it a number. Right, we can give it a number. Buffer, right? So, and it doesn't like the length because the length does not exist for this entire thing. Well, I mean, it's probably data, right? Okay, so we have a buffer. Can I then just do something like uint8 clamped array for the buffer and just set cute data? Is that something I can do? I think I can. And then I'm gonna try to construct a uint32 array out of this entire thing. So all of that so far compiles, and if I refresh this entire thing, it actually, you know, divided it by 4. Right, and multiply by 4, yeah, so that's how you have to do that, which is rather weird. Right, so you literally have to copy it. So because if you just try to put cute data in here, right, just to put cute data in here, it is not going to, like, you know, divide it by 4. Right, it will take each individual byte and expand each individual byte into 4 bytes instead. So to make it not expand that, you actually have to create a separate array buffer. Right, separate array buffer. And then copy this entire thing, and only then you have to do, which is kind of weird, isn't it? That is extremely weird. Can I view the data as the buffer? Okay, I can view it as a buffer, so that means I should be able to just do cute data buffer. Yeah, okay, so I can just take uint, that's actually pretty cool. Buffer array like buffer. Okay, let's see if that solves that problem. Okay, so that's a much simpler way of doing that already, because I was kind of worried that this is like the only way to do that, and it's just like really, really dumb. Let's take a look at the bytes themselves, right? Let's take a look at the bytes themselves. Do they actually look like the pixels? They do kind of look like pixels, not gonna lie. Some of them are 0 and some of them like pretty big, but it would make sense if we could view them as hex. If you know what I mean, right? It would be kind of cool if we view them as hex. Let's actually put pixels in here, right? So this is the pixels. Can I just like do, let's say 4 iterations, right? So we're gonna do 4 iterations. And we're gonna just like console log a bunch of things in here, like a pixels I, there we go. Right, so slow network. How? I'm on a local network, what the fuck are you talking about? Maybe it was the network lag after all. I think that was the network lag after all, boys and girls. Yes. Look at that. Look at that. Fucking localhost. Ah. Slow freaking network detected. You freaking... Domestic host has failed you, yeah. Thank you so much. Alright, we'll get a sub. Thank you so much for the Twitch Twitch Prime subscription. Fee Secuera. I hope I'm pronouncing your nickname correctly. Thank you, thank you, thank you. Really appreciate that. So the question is, how can I convert that to hex? Is there anything like hex? Like, okay, so let's actually Google that. JavaScript number as hex. Right. How can you even do that? How to convert decimal to hex in JavaScript? Okay, let's find out. Let's find out. Let's find out. So, oh, it's a toString 16. All right. So toString 16. Cool. What do we have in here? And it's actually eliminated the slow network. That's right. So toString 16 actually speeds up your network, right? So if you remove toString 16, well, I mean, okay. I don't know what caused that. I think my laptop is literally dying already. Is there any way I can pad this entire thing? Right, I wonder. I think the string itself had something for padding. Yeah, pad start, and how they specify it. So max length. Let's say the max length is going to be, since it's right, it has to be like 8, right? So that's what we're gonna have, and we're gonna fill all of that with 0, right? So that's how we're gonna be doing all of that. There we go, there we go. That's what I'm talking about. Can I do something like to uppercase? I can do something to uppercase, and now look at that. It looks like hexadecimals. Scheiße. Perfect. Actually perfect. So I know how to sort of like display the pixels, right? So that's actually pretty cool. Right, I'm gonna save this entire thing because I'm probably gonna be reusing all of that. So the thing I want to do now is I want to iterate all of the pixels for now, right? So I'm gonna just start from here, pixels length plus I, right? And I want to have you know, the object like unique pixels, right? Unique pixels, something like this. If unique pixels pixels I is equal undefined, we're going to essentially set this entire thing to 1. Otherwise, we're going to be incrementing it by 1. Right. So in the main question, so what's oh, it doesn't know what's up with that. So let's say that the key here is, it's supposed to be a number, right? It's supposed to be a number, but I think it will work. And it's a number from number to number, right? So it should be fine. Right, it complains about this thing, so what's up with that? Expected. Oh yeah, god damn it, like I've been programming in all of these modern Zoomer programming languages where you don't have to put parentheses around like if condition, and it's just like I kind of got used to that because it makes sense. And now I got back to this boomer JavaScript, right, that requires you to put these parentheses in there, and it's just like, oh my god. Oh my god. Okay, so let's take a look at some other stuff, right? So let's take a look at the length of the unique pixels. Is there any way for me to, I think it's entries, right? Or keys? I think it's something like keys and then length. Is that how it works? I'm not sure actually. So JavaScript count keys of object. I keep forgetting actually. I keep forgetting how to do that. So how to efficiently, why efficiently, just somehow. I don't really need efficiency right now, I just like need somehow to do that. Alright, so there's a keys, and I suppose that's one of the things we can do in here, right? So then we can just take the length of this entire thing, a boom, that should work somehow. Right, so let's refresh this entire stuff. 11. Right, And that's what I'm talking about. There's not that many unique keys in here, right? There's not that many of them. Right, so one of the things we probably want to do now, we probably want to iterate through them, right? So is there any way for me to say something like pixel in, right? And just go ahead and log this entire thing. It's probably either off or in, I don't quite remember, right? So it could be just like an index, but we can always just like, you know, yeah, it is an index, so I have to do something like off. Yeah, there we go. Now we're freaking talking. Okay, and I'm going to be using this magic in here, right, to turn it into hex so we can see the actual unique things in here. So this one doesn't really like 16. Are you expected 0 but got 1? Are you freaking serious, my friend? How is that even possible? Is that because pixels? Huh. Wait a freaking second. So this string is of number. So it does not consider pixel and because it's a string, it automatically converted this entire shit to string. Fuck you. You know what? I have an idea actually. I have an idea. What if I like do that in here? Right. So I say this is the color of the pixel, right? So that's the color of the pixel. And we actually accept, yeah, so I think objects, they're kind of like expect you to have strings in here. Keys always return this kind of stuff. Sucks. Scheiße. Scheiße. Absolute scheiße. But I think this should work. Right, and instead of like pixels in here, we're gonna literally use colors because it's gonna be unique anyway. Right, it's going to be unique anyway. Alright, so let's try to refresh this entire thing, and there we go, here are the colors. And what's cool is that, we'll be able to straight up use this as the style for rendering this kind of stuff, right? Because I want to match the color of the state with the color of the pixel in the original image. And in the transition table, right, right, so we have a transition table and stuff like that, right, we actually have associated color with the current state. Please watch your language. Oh, I'm sorry. Like, I keep forgetting that Germany is actually, according to my analytics, Germany is the second country most like that watches me. Right at the top is USA, and second one is Germany. Right? I shouldn't actually swear in German. I'm sorry. Even though I don't speak German, I don't know why I do that. It's just like such a satisfying word to say, I think. Right. I just love it for some reason. German language is beautiful. Anyways. Swear in Italian. Vaffanculo. I don't really know too many Italian swear words, I'm sorry. Hello from Brazil. Hello, hello. People are watching me from all over the world. Love from Antarctica. you guys got internet in Antarctica? Alright. So let me see. So we've got these things. So that means I can just like literally use this stuff in a style. But the problem here is that the colors are inverted, right? So here first comes the alpha, right? First comes the alpha. And then blue, green, and red. And this is because we're working with the least significant, with basically LSB order of bytes, right? So with LSB order of bytes. And essentially to use this as the color, I'll need to revert the bytes, right? I'll need to revert the bytes somehow. And I'm thinking what's going to be the easiest way to actually do that, right? Look at that. Look at that. It's a spaceship. This is a spaceship. How do you like my spaceship? I think it's a pretty cool spaceship. Anyways, so so where is the entry point? So one of the ways we can do that, we can try to invert all of that on the level of bytes, like literally bytes. Or we can try to analyze the pixels on a level of, yeah, we can actually try to analyze all of that on a level like by 4 bytes or something like that. That would be rather interesting, I think. So that means we shouldn't really convert all of that stuff into uint32. We shouldn't convert all of that stuff into uint32. I'm just thinking. Because you can just do something like function reverse number, right? Just a reverse number, right? Actually, we can say reverse uint32, right? And the problem with this kind of approach, right? The problem with this kind of approach is that x. Oh, yeah, so 32-bit value actually fits perfectly in here, so I shouldn't even worry about this kind of stuff, right? So, because it's literally 32. So let's introduce something like y. It's initially going to be 0. And what I want to do, effectively, in here, is just iterate 4 times, right? So something like this. Essentially, let's imagine that I have something like AA, BB, GG, RR, right? So I have something like this. So, and this is X, by the way. This is X. By doing something like mode 255, this is 255 in hexadecimal, right? By doing something like that, X mode, well, I mean, I can just put it in here. I actually extract R, right? I actually extract R. So extract this specific part. Right, so this particular thing will be equal to this entire thing. I can even do something like AND, right, so it will work like a mask, right, it will work like a mask. So then what I can do effectively here, I can just merge that mask with Y, like so. And that way I actually moved sort of R to here, right, I moved that R to here. And since I'm going to be doing that in a loop, right, I want to then remove that single byte from X, right? So I want to just do something like X, move to 8, and that effectively removes that byte from here. Right, so, and it would probably make sense to actually leave some space to the next byte in here, like so. And that, yeah, so essentially what we're doing in here, we're popping this byte from X and we pushing it into Y. Right, that's what we're doing in here. And that will effectively reverse uint32. And here we have to actually return Y. So we have a little bit of like a bit magic in here. But it doesn't really have to be a bit magic, believe it or not. It doesn't really have to be a bit magic because we can just replace it with division. Actually, this one has to be mod. This one is multiply by FF, right? This one is plus. We can even do something like this, right? So it doesn't have to be bit. And here we divide by FF, right? And that's how we do that. So it's kind of an interesting thing, right? It's kind of an interesting thing because so the bit operations should be more efficient. But we're talking about V8. I wonder, does the V8 compiler optimize this kind of stuff? Does the V8 compiler optimize this kind of stuff? It's a very interesting question. So it's a very interesting question. All right, so let's actually find out. It's kind of difficult to check with this kind of stuff, right? Because in case of the like actual not toy programming language, but a real programming language that are statically typed and compiled, you could use godbolt just to view what kind of assembly they generated. In case of a toy languages like JavaScript, I'm not sure, is there any tools that let you view the assembly that the JIT compiler actually generates, right? I'm not sure, because this is a toy language, right? So I'm not sure if such a serious tools are even exposed for such language. Maybe not, I don't know. So I swear, yesterday you said who the hell uses bitwise operations in 2023. Welcome to the Coding channel. All right. So, let me see. All right. Thank you for for the engagement in the chat. I really appreciate that. So, what we're gonna say. So I think this will work. Let's try to recompile this now. So I don't think I have to print bytecode maybe. Node print bytecode. Does it even exist? I'm actually really curious. Node help print byte. It doesn't exist. Okay, so let's refresh this entire thing and maybe this is one of the reasons why you have to use bit operations in this specific. Oh, anyway, so all right. So what I want you to do in here, right? So this is gonna be. I swear to God, people unironically program in this language. Holy shit. Ooh. So. Okay. Yeah, I think you can try to do something like this. Okay. So this is not a particularly great idea. I suppose I'm gonna go the other route. Right, I'm gonna go the other route of essentially just analyzing everything by 4 bytes, right? Because essentially what I have in here, right? What I have in here is basically a sequence of bytes, right? So I basically need to analyze them by force, right? Right, not how to say that, by force, not by force, but by force, right? So it's yeah. So you guys are right. I supposed to put 100. I'm sorry. So thank you so much. Yeah, what the fuck is this shit? Anyway, so I think it would be better to actually analyze them by force. So this one is weird actually. Why is it like that? Anyway, so let's do by force, right? So this is gonna be 4, and I think I'm going to like literally use this directly, right? So this is gonna be direct thing. We don't have a length for some reason. I'm not sure why. Where is length? Why can't I just get the length of the clamped thingy? Is that because I have to do data? I think that's because I have to do data. Maybe I'm gonna just do data like so, right? And if I understand correctly, this is length of the, oh my god, a clamped array, right? So this is a clamped array. And here, instead of this kind of thing, I'm gonna be doing 4, right? So we're gonna like increment by 4. We're gonna increment by 4. So the next thing we are going to do, all right, so I think is I'm going to just 8 clamped array, and I wonder if I can just do pixels pixels I4. Will that create the thing, right? So this is a single pixel, right? So this is a single pixel, and here we don't really need this function anymore. We don't really need this function anymore, and let's say that you know, bytes as hex string, right? So here we're gonna accept the bytes, which is uint clamped array, right? So this is a uint clamped array, and we're going to return to do, right? So it's not finished yet. So essentially here, right? Essentially here, what we're gonna be doing is just doing bytes as hex, and we can just pass the pixel in there. Right, and that creates the color, and we're going to be using that color specifically for all of that stuff in here. So we need some sort of a result, right? So the result is going to be just this, right? And let's iterate the bytes, le bytes of bytes. I wonder if I can do shit like that. I should be able to do it like that. Anyway, so byte, I want to do toString. Can I actually, yeah boy, to upper, right, maybe I also have to do pad start. It's going to be 2, this is going to be 0. Right, and what I'm going to do in here, I'm going to be appending that to the result, and that way I'm actually iterating all of that stuff in the usual order, which will not change anything, right? Which will not change anything. But we are talking about a sequence of bytes. We're talking about a sequence of bytes, which makes it super easy to reverse later, right? Which makes it super easy to reverse later. So does it work? I didn't see it working anyhow. So did it actually? What is going on? It is hanging. It is actually hanging, right? So I'm not really sure. So it feels like maybe it is not working the way I expect it to work. All right. So yeah, it feels like it just hanged. Let me close this entire stuff. So why would it hang though? Why would it hang? Is that because I cannot do that? Or maybe if I try to recompile, everything seems to be fine. Right, so there we go. Slow network, of course. All right, so let me think. I'm not quite sure. Like, it's like nothing actually tells me that this would be a problem. Right, what if I just put something like foo in here and illuminate the call to the bytes as hex? Right, I just illuminate this entire call. Because maybe that's the reason why it is hanging. Yeah, that's the reason why it is hanging. Okay, and it printed foo. As soon as I call to this function, it hangs. Right, but I don't understand why would it hang. So the only reason why I think it would hang is because, I mean, you cannot do that. Simply put. All right, so let's actually try to rewrite this entire thing. I don't know. Let I0 less bytes length plus I. Sure. I'm gonna actually keep it in here. Is that the reason? Is that the actual reason? Because I can't believe that that could be a reason. Okay, so there is some problems in here, but yeah, that's the reason. It's just like it's. I'm puzzled. I'm really puzzled. Like, am I? All right. So, what is going on? Excuse me. Can you just log the size of this thing? Why is it too long? I can't believe that. Like, I can't believe that it's just like not as straightforward. What the fuck is going on? I have no idea. Okay. So I should probably, yeah, I wanted to do it like that. Well, it's printing something. Okay, sure. It actually, okay. You cannot take a slice of clamped. I swear to God. I swear to God. You int8 clamped array is cursed. Like, what is clamped array? Right, why it behaves in such a weird way? It is so weird to me. Like, it doesn't behave like any of the uint arrays. Maybe I just don't understand what this array means. Type to represent an array of 8 bytes integers clamped. Right, its behavior diverges from any arrays that are not clamped. And it's just like so weird to me. Like, it always, I was trying to make a slice out of that, and it's not sliced. It's not slicing it this way. Like, it is not slicing it this way. It's just like so weird. Right. So clamped array. So let me read about it. Is there something special about it? It's a troll data structure. Yeah, exactly. Right, because if you feed it into uint32 array, it doesn't truncate it, it doesn't divide the size by 4, right? So it literally expands this, like each individual byte into 4 bytes. If it's not clamp, it will not do that. And it's just like, it's not obvious from the names of the structures that it will act like that. Right, so unsigned is clamp to, right, so the name only implies that the values are going to be always just clamped to the bytes, right? It doesn't imply all of these weird other behaviors that I encounter every time I work with this particular structure, right? So it's just so weird to me. I honestly do not understand, right? It's just like, why does it behave like that? Right, because usually if you have uint8 array and you're just trying to take a slice out of this entire thing, it would be size 4. Right, I can even try that. Right, so if I just like put it like that, right. Console log new int 8 pixels 4 length. And it's always something that I don't expect. It's always with this data structure that I don't expect. It's just like, dude, why are you like that? Why are you like that? Yeah. Yeah, exactly. It didn't slice it. It didn't fucking slice it. It's just so bizarre. So... why are they... who designed all of this shit? Who is the designer of all of these uint8s, uint32s, array buffers, and all of that weird fucking bullshit? Who designed all of that? I swear to God, it's so bad. Oh my God. And then people complain, boo-hoo, C hard. I don't understand. This is worse. This is worse than C. Like, this is literally worse than C. Like, in C, this kind of stuff just makes sense. They're all hanging out in Starbucks, yeah. We've got some subs. Thank you so much, Temple Cloud, for gifting 5 community subs. Thank you, really appreciate it. I swear to God. And it's always something stupid and unexpected in the web. And it's just like, oh my God. Why? Why would you design this shit like that? It's so bad. Alright, so that means I have to go back to the drawing board and redesign my route between different byte arrays slightly differently. Right, so there's this route of how to convert one bytes array to another bytes array. So this route was a failure one. Let's redesign that route. Sure. Okay. Swear to God. Okay, so image data, what do we have in here? So we have a uint clamped array. So we can probably start with the buffer, right? So, yeah, let me actually remove that. So, cute data buffer. So, because of that, can I take the length of the... and I can't take the length of the array like buffer, but I can take the length of this thing. Yeah, okay. So, but if I'm going to be doing this kind of thing, can I just make it an array? Can I just make it an array without this kind of thing? Okay, so will you work? Thank you! Thank you. Right. But I wonder if you just do clamped, it's gonna be 4. But if you just do that, it's still compilable. It's gonna be this. How is that making sense? It's just like... How? Who designed this shit? Who designed it? It's so bizarre. I swear to God, it is so bizarre. Oh. Anyway, okay, so I think this is less of a failure route. I think that, and it just always hits you like a truck, right? You never expect from what corner this kind of shit is gonna, like, you know, knock you down. Right. It's just, oh no, excuse me, when you convert array buffer from the clamped, it actually doesn't clamp it because blah blah blah, the standard. Yeah, sure. Ah, I'm going fucking insane. It's just like, oh my god. And people internalize this shit. And people defend this shit on Twitter and on YouTube. They fucking like it. They fucking love it. They're defending that. Literally Stockholm Syndrome. Literally. My god. Okay. Woo! Alright, so what I want you to do, buy this hex. So this time, I can actually take you into array. But Zoisen, there's a reason for all of that, because don't you see, Zoisen? Okay. Sorry. So... So seems a good they'll have this shit for real. I mean, if it pays money, if it pays the bills, right? If it buys them good coffee at Starbucks, I can see why they would like it. I didn't know you could speak gibberish, my native tongue. Oh yeah. There's no good coffee at Starbucks. I've no idea. I've never been in Starbucks, actually. So, I live in Russia, my comrade. We don't have Starbucks. We have red Starbucks. I'm sorry. Anyway. This should work, I think. I think this should work. Do we have any errors? We don't have any errors. And okay, it's all zero. It actually all turned out to be zero. So that, all right, that didn't work as well. We don't really know why yet. We don't really know why yet, but that didn't work. I wonder if I can convert it to a string. Is it possible? Okay, so it is possible. All of them. Oh yeah, I see. So I forgot to put I in here. All right. I almost had a heart attack after this trauma of converting between clamped arrays and buffers and not clamped arrays and buffers, and realizing that there is a difference in behavior because the Starbucks people decided so, and I'm stupid. I thought I encountered yet another traumatizing experience. I just forgot to put I instead of zero. Okay, everything's fine. The situation has been saved. Okay, so all right. Okay, this is what I wanted to see. Yeah. All right. So now we want to actually call the Starbucks people. The Starbucks people are coming. Look, why my local host is slow again? I should never touch any of the web technologies ever in my life. Like, holy fuck. It's just like, it just doesn't work for me. This is probably because I don't have a Starbucks. You know what? This is because the Starbucks closed in Russia. That's probably why. If we had a Starbucks, the IT industry in Russia would have not collapsed. All people say that the IT industry in Russia collapsed because of the sanctions imposed on Yandex. No, this is bullshit. The IT industry in Russia collapsed because the Starbucks left. That's why. Because without the Starbucks, none of this shit works. It just like doesn't work by definition. So you need a Starbucks for this kind of stuff. So yeah, pumpkin spice latte. Yeah, so without the pumpkin spice latte, it just like doesn't fucking work. So that's the most powerful sanction you can apply to anyone. Is just like close the Starbucks. instantly. The entire IT infrastructure just fucking collapsed. So, is industry in Russia? Of course. Don't you see? Like I'm in the middle of ruins, right? Nothing works. My local host is fucking slower than my external connection. The whole IT infrastructure fucking collapsed inside of my local laptop. So everything is collapsing. Anyway, so finally, after an hour of work, I managed to analyze unique pixels. And actually even convert them to colors. I actually managed to convert them into colors. One of the things I would like to do, by the way, chat, is to draw these specific unique colors. Like on the canvas, so we can see all of the unique colors in here. I think that will be actually kind of cool. Right, so let's take the width of the canvas, right? So if I remember correctly, the width of the canvas is app width, right? So app is the canvas and we can take its width. So then we can take the colors, right? So the colors is basically unique pixels, object keys, right? So this is object key. So this is how many like colors we have in here. We're gonna take the colors and we're gonna divide by the length of this entire thing, and this is effectively the size of a single like cell in which we're gonna draw all of the colors, right? So let's actually call it something like cell size, right? So this is sort of like a cell size. Okay. So and let's iterate through all of the colors, right? So let color of colors, right? Let color of colors, and let's just do ctx fill style, right? And we're gonna set the color of that unique pixel to the fill style. Though we probably also have to put the hash thing in here, right? So because otherwise it doesn't read like an actual style, right? So you're supposed to use like a camel case or some shit like that. I don't know. I'm not a web developer. So and the next thing we need to do, we need to fill rect, right? So we need to fill rect. We're gonna start at 0. Actually, no. Can I have indices and values simultaneously in JavaScript? Starbucks people. Can I have that? Okay. So probably have to do shit like this. There's entries, but I already have an array, so anyway, so we're gonna start with what? X. It's basically I multiplied by the cell size, right? So this is X, position of the X. In terms of Y, let's keep it 0, right? So it's gonna be the first row. Then width and height is gonna be cell size and cell size, right? There we go. So that should work. So I didn't work. What's up with that? So left hand any ended up with a boomer ass C loop. Anyway, so let's continue. Look at that. These are all of the unique colors of that image. Isn't that pog? I think it's pretty freaking pog. What the fuck? Look at that. Look at them colors. Look at them colors. Yeah, boy. Yeah, boy. So if we take a look at the original image, actually, right? So if we take a look at the original image, so I probably have to use the feh, right? Yes. And I probably have to do some shit. Yeah. So this is the image that we're analyzing, right? And these are the colors. This is a very cool palette. I'll give you that. So the props to the author of this specific piece. The palette is actually very satisfying. I really like it. It does feel like a, yeah, it does feel like a terminal thing. All right, it does feel like a terminal thing. So that's actually kind of cool. All right. All right, so essentially we've got a list of all of the potential states, right? We've got a list of all of the potential states. And that means we can already kind of generate some of the stuff, right? So automaton, right? So automaton is actually an array of states, and each state is the transition table, right? It's a transition table. So we can already just basically say, okay, so how many unique pixels you have, just create that many transitions in here. So, but the transitions themselves, how can we how can we create them? Right. One of the ways I was thinking how we can do all of that. So let me actually see. Yeah. So I'm gonna do it like that. We can take one specific image, right? We can take one specific image and maybe start from the left upper corner, right? From the left upper corner, right? And for instance, here we have just like an empty thing, and we're gonna leave it as it is, right? And then we go to the basically the next one in here, right? We're gonna ignore everything to the right and bottom and diagonal in here. We're only gonna analyze maybe something to the left, up, and diagonal there, and essentially look how many neighbors we have in there. And for this specific amount of neighbors, we're gonna make a transition from an empty one to this one, and we're gonna try to analyze all of that diagonally, like so. Diagonal like so, creating transitions for diagonal for the entire picture, hoping that maybe it will create a cellular automaton that recreates the original picture, or maybe not. So I don't really know how it's gonna work out, but this is basically an idea. Another idea I had is to create a stable cellular automaton. Basically take a picture, and for each pixel in here, create a rule. With this amount of neighbors, stay in that state always, right? And if then you can place this entire configuration onto the canvas, and it will stay stable because the cellular automaton is actually like will basically keep it stable. And then we can try to maybe remove one of the pixels and see how it falls apart or something. That's actually a very interesting idea. Huh. I really like that. So maybe this is the first thing that we can try to do, right? So basically take one character, right, and make a stable cellular automaton that just preserves this picture, right? And then try to like change something and see how it falls apart, maybe. Right. So that's actually kind of cool, right? But to do that, we probably need to separate all of these things into like smaller pictures, right? Is there any way, by the way, to split the image data into smaller image data? That's a very interesting question, right? So if I already have an image data, is there something I can do to make a smaller image data? All right, so this is the image data. Right, so already have that. So there is a predefined color space. I feel like there could be some problems with that, but we can Google that up a little bit later. We can Google that up a little bit later. All right, so I want to make a cup of tea. So to do that, we'll need to make a small break. So, okay, go. I guess the time has come to continue with this thing. Right, so let's continue. I really like to split this into like separate images, but I don't know how to do that with image data, right? How can I do that with image data? Maybe the time has come to ask Chat a CCP. Hello, Mr. C. I have image data. How can I split it into sub images? Yeah. Wait, what is this? This is chat as Python code. This is chat CCP. I don't have an access to ChatGPT because OpenAI banned it in my country. I can only have an access to ChatCCP. Right, so it's a Chinese website, which is also like a front end for GPT 3.5, but I have an access to it at least. Right, so I should have actually specified that I wanted JavaScript, right? So it didn't, like, it thought I'm talking about Peel. It thought I'm talking about Peel. Okay, I'm gonna fucking delete your message. Right, probably should start over. I think we should start over. Let's delete it. All right, so. Sub images. I have in JavaScript in browser into sub images, also image datas. Hello, I can definitely help you with that. To split image, blah, blah, okay. I see what you mean by that. So you want to do that through the context. This front end looks better than GPT-MO. Well, yeah, by the way, you can give it a try. The cool thing about this thing is that it doesn't require any authentication. You can just like open it up and use it. You don't have to log in or anything like that. And it's probably going to be closed in a month. Right, it's just like one of this. It's a ChatGPT from Wish, right? That's what it is. It's a ChatGPT from Wish. It's just like we have ChatGPT at home. That's what it is. And I probably read your messages. Yes, so so I know that these messages are going to be read personally by Xi Jinping, so that's why I address them like that. Is GitHub Copilot also blocked? Probably. I never checked it. Right. Alright, so it basically suggests to do get image data, so you can basically take sub images of, but it's from the canvas. So here is the thing, it's from the canvas. So if we do get image data, yeah, so, and it allows me to get the sub images, but the canvas image data is not image data, if you know what I mean. Right, so if I take a look at the image data itself, I simply cannot do this kind of stuff. Right, does that mean I have to do that stupid trick of the off-screen canvas again? The same trick I was trying to avoid all the time? Is that what you're telling me? So let me see. So so what I don't have a canvas. I only have image data. How can I split it into smaller image datas? I see. In that case, you can create new image data object to represent each sub image. Here an example. Okay. Sub image width. You can create new image. Ooh, this is the painful code. This is probably the most painful code I've ever read. Holy shit. Oof. Not even pixel by pixel, but byte by byte. Oof. 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 This is a pure torture, really. Okay. So let me think. Maybe let's actually not do that, right? Let's actually not do that, at least for now. Let's analyze the whole image, right? Like, let's literally analyze the whole image and create this thing, because we can spend like a lot of time battling with Web API I know that. Right. Imagine Portia, a student who can't tell if answer is good or bad. Well, I mean, this answer will work, right? This answer will work, but I mean, it's just like it's painful. So that just means that the web doesn't really have a proper way of doing that. Right, it doesn't really have a proper way of doing that. So let me think. So we're gonna just basically try to create a stable cellular automaton out of those things, right? So that's how we're gonna be approaching this entire stuff. All right. So okay, how we're going to do this entire stuff. So here are unique pixels, right? So this is the unique pixels, and maybe let's call them like maybe colors, right? So I already did something like colors below. Yeah, there we go. So we don't really need this kind of stuff anymore. Yeah, we don't need it. I need to create my own automaton. My keyboard has died yet again. What the fuck? Dude, no. Chat. KGB hacked me. KGB hacked into my computer, and now I cannot use my keyboard. What the fuck? I don't know why, by the way. Sometimes it just like dies. Oh yeah, there we go. So we deflected the KGB attack, so I gained control on my laptop back. That's because I said -100 social credits. Yeah, that's probably why. Okay, so I need to create a new automaton, right? So this is going to be const stable. Let's just call it stable automaton, right? And it's an array of states, right? And as far as I know, you're supposed to actually create colors len, right? And we're going to fill this entire thing with just like empty objects and whatnot, right? So we're filling it with the empty objects. Though it's not particularly great to do it like that, if you know what I mean. Right, so maybe we have to map it, right? So I'm gonna take each individual thing in here. Maybe I don't even care what kind of things I get in here. Right, and what I need to return, I actually need to return a state, and a state is these things, right? So state is this thing, interface state. So color, that means, by the way, that we can just take the colors and map them. Yo. All right, that's actually very cool. So the color is basically the color, and here is the default. So this is basically the default transition if we can't find any transitions in this table. So the question is what could it be? Maybe we can say, okay, stay in your own transition. Right, maybe say, or maybe we can just basically short circuit it to 0, right? So to the first one. And in terms of transitions, right now, all of the transitions are empty, right? So we don't really have anything in here. There we go. So we basically created sort of like an initial thing in here, right? Does it make sense? Okay, that's pretty cool. And that's pretty poggers, I would even say. We can even print the cellular automaton that we just constructed. Right, we just constructed it, so let's actually refresh this entire stuff, and there you go. We have 11 states, and for each state we have a color, default to 0, and so on and so forth. And it's actually very convenient that the default one is actually the one with 0, 0, 0, 0, 0. So what this table means in the context of JavaScript automation. Stable, the context is not JavaScript automation, it's a JavaScript automaton. Right, we're making cellular automaton. So the stable one is the one that just preserves the picture, right? So if we're gonna put this picture onto the board and we're gonna create a cellular automaton that, given that picture, will just keep it steady, keep it stable. That's the idea. Right, because that's the most obvious, easiest thing to implement. Because essentially what you do, you iterate through each individual pixel of the picture. You look around, look at the count of the neighbors, and you use that to basically stay in that specific state. So it just naturally gives you the rules, the transitions between the between different states and stuff like that. Does it make sense? Make sense? Right. It's all related to all of the previous streams that we did on the topic. So right. So this is the problem with making multi-episodes projects is that all of this stuff is already explained, but before you need to watch previous episodes where we like dedicated the whole episode describing all of that stuff. Right. So, and I already talked about it and already explained a lot of these things, but since this is a stream, not everyone watches the episodes, I have to keep repeating things over and over and over again. Right. So, oh boy, I forgot what I was doing. So I need to start iterating through the pixels of the original image. So the problem here is that I need a mapping from a color to a state. Right, so it's rather easy to create such mapping, I think. Right, it's rather easy to create such mapping if we just simply iterate all of the colors like so. Right, colors length. Right, so this is a colors length plus I. And we had the color to state mapping. Right, so this is a color to state. And in here, it's just a reverse mapping, you know. Right, so we just do colors, it's I, and we just do it back. So maybe there is a way to find all of this thing, but I'm not 100% sure. So this thing, I'm pretty sure, has to be something like this. So we're going to map the string to a number. Mapping the string to a number, and that's basically what it is. And so then we can use, when we're analyzing the pixels, right? When we're analyzing the pixels, we can try to do all of that. So we got the subs from Frantizic 1917. Thank you so much for tier 1 subscription with the message. OMG, wow, it's already my 10th month anniversary. I thought I just had my 9-month. Thanks so much, Zozingus. I started my first C project inspired by you, doing a little theorem prover for fall. I don't know what is the fall. I really miss algebraic data types, but we're gonna make it. Okay, I'm really glad that you enjoy my streams. And good luck with your project. Thank you. Thank you. All right, so we have a reverse mapping, right? So we have a reverse mapping, so that basically means it should be relatively easy for me to now start analyzing things around. So the problem with analyzing things around is that we essentially have pixels, right? We essentially have pixels. And that means we have to start iterating this thing again, but slightly differently, right? So, okay, that's not particularly convenient, but we can try that, right? So this is going to be y, right? And then cute height, right? So this is going to be that. And then we're gonna, so we are iterating by rows first, and then we're going to be iterating by columns. And what I need to be able to do, right, what I need to be able to do is that I need to be able to, oh man, I need to be able to get this kind of stuff, but this is not particularly convenient. That's the problem, right? So I don't want to work on the level of pixels anymore, which means that I probably want to have a function. Right, I probably want to have a function that just converts all of the, like just pre-processes all of that stuff, right? So I'm going to give it an image. It is going to count its states, right, and give you the board of this. This is actually very cool, I think. This is actually very cool, right? Basically image to sort of like process image, right? Process image. So in here as an image, we're gonna take maybe image data, right? So this is image data. And here what we're gonna return, all right, we can actually return a pair. So we can return a board that contains, that is the size of the image, right? The board of the size of the image. But instead of colors, it is going to have the numbers that represents each individual state. And we're also gonna get an initial automaton that contains, you know, the colors and empty transition tables and stuff like that. So I don't think it works that way, right? So it complains about this kind of thing. What does it say? Function whose declaration type is neither it's just like it wants to return a value. Okay, sure. Jeez. All right, can it just return null? It probably cannot return null, right? Because both of these things are not nullable, right? But I don't think I care about it too much. Anyway, all right, and essentially, I need to come up with the name of this thing, right? So process image. Image. I don't know. It's like sort of like an initial step in processing that specific image. But I don't know how to name this entire thing. Maybe like normalize image, automaton. Maybe that's a way we want to work about all of that. So okay, the problem here is that board actually kind of has a fixed size, right? If you know what I mean, it kind of has a fixed size. And we hard coded it. So what I'm thinking is that maybe board has to be some sort of an interface, right? Which also has a width and height, right? And maybe as cells, it is going to have an array of cells. Yeah, so it's kind of similar to, like, it's going to be flat. Yeah, let's just actually keep it flat. I think that's a pretty good idea. Right, because then it will make it easier to construct this entire thing. Right, it will make it easier to construct this entire stuff. So, yeah, so this is the board, and let's just keep it like that. So when we're creating a board, right, we probably want to accept the width and height, right, so this is going to be width and height. And here we're creating this entire stuff. So let's say that width is going to be the width, right? So the width is going to be the width, and height is going to be the height, and the cells, well, it's going to be probably array width by height, right? But field with 0, right? And we're going to return this entire thing. So interestingly, we'll have to go through a lot of these things and basically factor it out. Basically like refactor all of these things, right? Because the board has changed its, you know, the way you work with all of that, right? I wonder if I can have some methods in here, right, that can help you. So do we have to make it a class? Right, because it would be nice to have some sort of like a get, where you would have x number, y number, right? But I'm pretty sure this is not how it works, right? So we have to make it a class, right? And then here we would do this, this cells, x multiplied, actually no, y multiplied by this height plus x, right? So, and I want this thing to return the cell. So I don't think this is how it works, so we'll have to work with all of that manually. Okay, anyway, so let me try to recompile this entire thing and go through the compilation errors. All right. So here we are counting the neighbors, right? So the board, that means we have to do cells, row, multiplied, so the current row multiplied by the board width plus c, and that will kind of work, right? But again, it's not particularly convenient. Can I just have a method in an interface without a class? I actually don't think so, right? I actually don't think so, so we'll probably have to turn it into a class, right? So this one, can we just make them public? Right, so it complains about things in here. Width has not initialized and is not... Okay, so we just need to do something like constructor. Right, so this is going to be width, which is going to be a number. Then it's going to be height, which is going to be another number. Right, and the way we're going to work with that is we're going to initialize all of this. Height and cell. I can just steal this code from here. Alright, so we're going to steal this code from here. And that should be it. Alright, so that should be basically it. Alright, so the way I want to do that now, I want to do get, which accepts x. But I'm not sure, should it take first row and then the column? Maybe it should x and y. I think it's going to be better. Return these cells y multiplied by this width plus x. Right. So this will make it a little bit less error prone, hopefully. And we probably want to have something like set, right, which sets the value of the cell, doesn't really accept anything. Right, so this is going to be cell. We can also maybe accept a cell number, like so. Alright, so I think that would make sense as well. Alright, so, excuse me, let's go to the compilation errors. It can take some time apparently. It's very, very difficult. Alright. Get, but since first has to be X, it's CR. Alright, so we have to be a little bit careful in here. Alright. So next, set CR. I should probably rename them to X and Y at some point. Yeah, there we go. So next we set C and R to this specific thing, to this specific transition. Then get C R, like so. This one is interesting. So since I have methods, maybe I can somehow simplify all of that stuff. Maybe not. Shouldn't do that. At least for now. At least for now. Alright. And we're just setting it like that. So let me actually rename this kind of stuff. So this is going to be Y. And here's an interesting thing. Since board actually stores its own board rows and board columns, I don't think I need to pass this kind of stuff, right? I don't think I need to pass this kind of stuff. So the problem with this kind of stuff is that the board, the current and next, they can have different sizes, right? So that's kind of the problem. Maybe what I'm gonna do is I'm gonna just like assert that the current width is equal to next width, and the same with height. Right, because that's basically what we're expecting here. It would be kind of cool to maybe have this as runtime values, right, as generics, so to speak, if you know what I mean. Right, so that way it will 100% match. But I'm planning to use board as actually... so I want to have boards that only have size at runtime, right? So I also want to be able to do this kind of stuff. But maybe these two types should be different. I think these two types should be different. So the board, I don't know. So I just need to continue like doing this kind of stuff, like, and see how it evolves over time. Right. So this is going to be Y, and the current height plus Y. So X, current width plus X. There we go. So we get that. Count neighbors, this one can be X, Y, X, Y, so that already like way more readable than CR, as you can see, right, it's way more readable, X, Y, and makes way more sense. I really like how it goes, and we're done with this entire thing. Okay, Okay. So we have another thing in here. So we have a rendering. So I think I need to remove this kind of thing. I think I need to remove it. Right, to sort of encourage the compiler to tell me that I shouldn't use this thing anymore. Right, so this one is width. And no. This is actually Y. Right, so yeah. So this is going to be Y. Board height. So this is X, board width, X. Okay, so we have a little bit of a problem in here. So what is this? So I suppose this is rectangle related, so I'm going to prefix it with R to indicate that it's a beginning of the rectangle, right? That's what it is. Get XY. There we go. So automaton, I board get XY, and we set it in here, XY, blah, blah, blah. Actually, it has to be RX, RY. There we go. So we've got some sub. Would you look at that? Thank you so much, Zakisimo, for Twitch Prime subscription. Thank you. With a message, thank you for Poke Stream. Thank you for a Twitch Prime subscription. I'm really glad that you enjoyed the streams. All right, so what else do we have in here? So count neighbors. This one is interesting. All right. So here we accept, actually, right. So X and Y. Right, we have to change them to... Oh boy, this is dangerous, right? So I'm effectively changing the order of these things, so it can fire back kind of badly at some point. So I'm not sure. So I have to be super careful. Though I don't think in this specific case the order matters. Alright, I don't think the order matters. Right, YX. Ooh. Alright. So board height, because if I make a mistake anywhere in here, it's gonna bite me in the ass so badly. All right, so then we have get XY. There we go. Seems more or less good. But this needs to be done, right? So I need to abstract away the board stuff. The board stuff. Okay, so when we're rendering this entire thing, right, so this is a calls, that means board width, and this one, board height. Okay, so then I'm iterating this kind of stuff. All right, that's cool. So what are the rest of the... Is that it? I can't believe that is it, actually. All right. So here we have a normalized image. Right, I'm gonna actually turn it off right now because I want this entire thing to compile. Right, I want this entire thing to compile. Because we need to test how all of that works. So, alright, so create a board. So initially we had the board size, and let's actually say it's 64. So for this kind of stuff I just do board size, but then at some point it's going to be more flexible. Oh, okay, so it means I should be able to do new board, right, because I created a class out of it. So board columns when we are... So this has to be current board width. Current board height. Alright, so that looks good. Row and column, So this is X, this is Y. Get X, Y. I has to be set actually. Yo. So, underneath you changed R0 to, yeah, okay, count neighbors, thank you so much. Because so I have to actually go to count neighbors to where we call them. Though, in here, but thank you for telling me anyway, right? So because I changed the order in here, and I changed the order in here, but then here, yeah, so everything's fine. But thank you for telling me, right? Because it's one of the places where it could have blown up, I suppose, right? It could have blown up. But I think it's not a problem specifically in here, right? I think it's not a problem specifically in here. Alright, so let me refresh this entire stuff. I still have a slow network, right? I still have a slow network. Let me take a look. 64, 32. Let's refresh. So because I want a bigger stuff in here. And okay, so I'm using the Brian's brain. Seems to be working fine, more or less. So one of the things we can do, we can actually divide the height by 2. Right, so that way it... Oh yeah, it actually makes it like this. You know, it would be kind of cool if the canvas also preserved the ratio. Right, it would be kind of cool if it preserved the ratio. So, but I don't think I want... No, we'll need to do that, because at some point I want to take this and turn it into like canvas, render it as a canvas, and it's not a square, so that means we need to be able to just do that. Right, so we need to figure out the ratio, right, so we need to figure out the ratio. So here what we do, we set the width and height of the canvas, so probably this is not where we have to set it, though we can say that width has to be this, right, so we can say that width has to be this. Alright, so here we have a current board. So since next and current board has to be the same size, I can actually do a little bit of a trick in here. Alright, so board width and current board height, so basically they're always the same. Okay, so we can say that width, actually height of the current board related to its width, and this is the ratio that we have to apply to the width of this thing and apply it back to the height to restore the same sort of ratio, if you know what I'm talking about. Right, so the ratio between height and width is this, and we apply the same ratio to width to get the height. Does that make sense? And that way we will create the same ratio in here, as you can see. And it's always square. So, and so in here we can even maybe multiply it by 2. Right. So here we sort of lock width to be 800 pixels. Right, but then we compute height relative to that according to the ratio in the current board. So something like that. Right, and it kind of works, I really like that. And let me try to just run. Well, I mean, we can try to run this thing, but I want you to actually run Game of Life. Right, and I want you to just like see how Glider is going to basically react to this entire stuff. The glider seems to be working. This is actually way better, because now I can use arbitrary stuff. Nothing is broken, surprisingly, right? So if it compiles, it works, am I right? Fellow recreational programmers? Pokers, yesu, 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 kawaii freaking desu. Yo, yo. Okay. So what we were doing, essentially, what I want to be able to do, right, I want to be able to give the image data and get the board that I can then set as the, for instance, current board. Right, so let me just go ahead and copy paste all of that stuff in here. Right, maybe one of the things first we have to do, we have to create a board. New board is going to be essentially image width and image height, right? So that's the new board that we'll have to return eventually. And then, okay. So how we're going to be iterating all of that? We're going to be iterating by y's. All right, so this is going to be height and y plus plus y. All right, and then this is going to be x, width, x. All right. So now let's take the data. So here x and y. So I need to do y multiplied by the size of the row, but also multiplied by 4, because the size of the row is not width, it's width multiplied by 4, because we have additional stuff in here. I have to replace cute with image, actually. There we go. So plus x multiplied by 4, I think. Yeah, that's true. So maybe we can then basically move this stuff here. All right. Yeah, that makes sense. Okay, and then we construct this thing in here. And there we go. So we don't really need the board right now, but we may need it in the future. So essentially, when I do unique pixel, I map a color and a number, basically how many times it was encountered, but it's not a useful information. I don't really care how many times it was encountered. I really don't care. What I probably should store there is the number, is the current state, but that also means that I need to have a counter starting at 0, right? So if this color is equal to undefined, I have to set it to count plus plus, so I basically increment the state. And then, right, what I have to do, I have to actually do board set x and y to that specific thing in here. So which kind of means that maybe unique pixels should be called something different. I think I know how to call it, color to state. That's what it is. Yeah, this is the color to state I want you to compute initially. Yo, the code write itself. That's actually pretty poggers. Alright, so, and we've got the board, so I can return the board. But also I need to create an automaton, right? So that means I need to do object keys. Okay, so I'm gonna do something like automaton. Alright, automaton is going to be equal, so this is a const, object keys color to state, and map this entire shit. So color, and we need to return this state. So this state interface. I think we're going somewhere. Hopefully not to a prison. Okay, color default, let's reset it to 0, and the transition table is gonna be actually empty. Yo. And that's it. We implemented the normalize image. So normalize image literally takes the pixels of the image and returns you a board with the state of the unique, like with the pixels replaced with their corresponding states, and an automaton, like empty automaton, with also the same states, right? It just sort of like prepares the image, so to speak. I don't know, like how would you call something like that? How would you call such step of processing the image? Like I cannot come up with like a good name for such step. Right, so there should be some sort of a fancy name for this kind of thing. Right. So, and that allows us to do the following thing, image to board, but it also converts it to automaton. Synthesize, that's a very good thing. No, image to board doesn't really work because we also have automaton, right? So because you construct them simultaneously, right, you construct them simultaneously, and this is very important. So I like synthesize because it's a fancy word. It makes it sound like you're doing something serious. It's like dynamic programming, right? It has nothing to do with being dynamic nor programming, well, almost, but it sounds cool. right? So it sounds cool. So this kind of step, because it's so fucking meaningless, it needs to have a fancy fucking name, like a synthesized instantiation of cellular automaton. So maybe we can take two fancy words, synthesize and instantiate, and call it synthesized. Oh. Transcendental adhesion of image. That's a good one. All right. Oh shit. Okay, that's a good one. That's what it is now. Thank you so much, I really like it. Transcendental. Yeah, we provide this thing, and really thank you. That gives us the cute board and cute automaton. And this is Job Security 101. That's right, Job Security 101. Okay, so here's the interesting thing. If I set essentially the queued board as the current board, what is going to happen, right? Transcendental adhesion of image. Love it. Okay, and it blew up. Cannot read property color of undefined. How did it compile? God damn it, TypeScript my ass as usual. So, all right. So what you didn't like, 37. So it didn't have a color, surprisingly. All right. Didn't I provide this kind of thing in here? Okay, so I think that we need to print them. So I'm gonna do console cute board automaton. Right, let's refresh. So board width 64 and cells, right? So, and this is how many of these things we have, and we have like value 0, 1. That makes sense. That makes a lot of sense actually. Oh, I see. So you also have to set the automaton to the cute. Oh, they're connected. I completely forgot that boards and automaton are connected. They are in fact connected. And since they're connected, maybe they have to be the same thing. Maybe, I don't know. Queued automaton. There we go. So we didn't really need a board size anymore, but I mean, that's fine. And it didn't work, surprisingly. Yeah, it literally did not work. It didn't render anything. I wonder why. So what if I set next? It's not supposed to really render anything. So keyboard. So let's see. Slow network. You are slow. So of course. Do you guys see the problem? Do you guys see the problem? This is not a style. This is not a color. The color has a hash sign in front of it. Who would have thought that the problem is that dumb? Like, I swear to God. Anyway, so ooh, and there we go. So these are literally the states, right? These are literally the states, and I can remove some of them, right? So as you can see, I can start removing these things. All right. So, and when I do the next step of the cellular automaton, all of them are disappearing, right? So the next step of the cellular automaton, all of them are disappearing. That's pretty cool, right? So we literally transformed the image into cellular automaton. This is so cool, actually. What the fuck? one of the things, like, it would be kind of cool to just run Game of Life on them, right? Just run Game of Life of them, but I mean, this thing has more states than Game of Life, so it's not going to work that easily, I think. Right, and we can't really easily merge automatons. Or can we? That's a very interesting question. Can we merge automatons? So essentially, what if we had a function merge or maybe add automaton, right? So here we're gonna have the destination, the receiver, automaton, and here we're gonna have a source. So the idea is going to be iterating through the source and taking its transition tables and merging them into the transition tables of the corresponding states to the destination. Right. So that's the idea. And let's go ahead and try to do that. So here I'm going to be iterating this kind of thing. 0 less src length plus I. Right. And in here, so this is a state, right? So that means I want to do a state. So one of the things I assume in here, by the way, that console log src, the amount of states in source is less or equal than destination. Right, it's quite important because if it has more, that means the destination just will have the states it doesn't. Yeah, so that means the source has a states that destination doesn't have. Right, we can handle that, but I'm just too lazy to do that. Right. So I'm just too lazy to do that. And in here, right, so if I do a transition, right, it's going to be t less than src as transitions, right, src as transitions. But the problem here is that we also somehow need to merge the default, right? So we need to somehow merge the default. Oh yeah, console assert, yeah. Right. So this one, it's not particularly important to do this thing. That's the problem. It's not particularly important to do this thing, but I kind of want to do that. So, I already streamed for 2 hours, god damn it. So that means we probably want to make a small break. Right, the reason why I'm doing all of that is because I want to try to run one of the existing cellular automatons on this specific thing, just to see how it's gonna go. Right, but I think I need to make a small break because I'm a little bit tired, right, so, and I need to make a cup of tea. So, let's make a small break. I think this is a dumb idea. You know why? Because, if cellular automatons have different states, their keys in transition tables are also going to be different. Right, so the size of the key in the transition table has to be equal to the amount of states. And if the states are different, the keys become incompatible. And so each key essentially contains the amount of neighboring cells of that specific state. So basically here you have to have 4 cells with the state 0, 2 cells with the state 1, and 2 cells with the state 2. That's basically what this key means, right? So, and you may think why I'm using you know, strings in here. What if a particular amount of states is going to be more than 10? Well, the whole amount of neighbors cannot be bigger than 8. So none of these values are ever going to be bigger than 10 or even equal to 10. They are never going to be bigger than 8, in fact. So that's how it works essentially. That's how it works. So because of that, this is a very dumb idea, so I probably should not attempt that. So we're not gonna do that. So I was just thinking, what if I just take this thing and try to apply one of the existing cellular automatons? What's gonna happen? But maybe I shouldn't do that. Anyways, so let's actually try to build a stable transition table, so to speak, right? Let's give it a try and see how it's gonna go. So to do that, we need to iterate through each individual pixel of the queued board. Finally, I can easily do that. Finally, I have all of the data structures that make sense and I don't have to work directly with pixels. But we will do that. I need to acknowledge yet another sub, yet another person throwing money at me like crazy. Mask of Winters, thank you so much for Twitch Prime subscription with the message, been learning a lot from your streams, sir, your giga chat of programming. No, I'm really not, right? I'm just saying bullshit with a confident voice and just writing, you know, bullshit projects, right? That's what I do. But I do that for recreational purposes, so my goal is to have fun in here. But I'm glad that it still inspires other people to actually do their own things. Nice accent though, thank you. I actually practiced for a very long time to have this beautiful, beautiful Slavic accent. I was so dedicated to having this accent that I moved to Russia. So dedicated, I was fucking born in Russia just to have this beautiful accent. Thank you very much. Alright, so let's iterate through the pixels. Cute board, height, plus y. Then we're gonna be iterating the columns. Cute board width. Do I sound like a villain? Alright. I would swear it's a French accent. Yeah, sure. Okay, so what we can do in here, right? So we now want to count the neighbors, right? How do you count the neighbors? Count neighbors. So to count the neighbors, you need to have an array of the size of the amount of states, right? So you need this neighbors array, right? So that's what you need to have in here. So we can just take cute automaton, right? So cute automaton, and we're going to fill it with the length. Cute neighbors, count neighbors, I mean, and let's see. All right, so we're going to provide the cute boards. We're going to provide the neighbors, and we're going to provide X and Y. We're going to provide X and Y. Alrighty. And there we go. So, and the neighbors now is going to contain the amount of neighbors of different states. So the way we convert this thing into the key, the transition thing, is like this, right? So we basically join this entire thing with empty string. Right, we can even try to maybe print all of these things in a console just to see how they look like. Right, so we're looking at the neighbors. It's probably gonna take, yeah, that's fine. Right, here they are. That's all of them. It's all of them. Actually, not that many. It's probably not all of them. Right, some of them were suppressed because it's too much data. Though it's supposed to be like 3,000, so I didn't really see 3,000 here. So I think it didn't print all of them. Right. Okay. So, and what I wanna do. So essentially, we can say cute board get X and Y. So this is the current state, right? So this is the current state that we have. So in the transition, in a cute automaton, right? In that specific state, right? We take the transition to here. And we can say that while being in that specific state and having these neighbors just stay in that state. That's basically what we want to do in here. Right. So as I already said, we're constructing this stable cellular automaton. Right. So we just go through all of these things. And if you see, if you are in this specific state and you see these specific neighbors, just stay in that state. So interestingly, we may have a situation, right? We may have a situation that when this thing is already defined, right? So maybe we need to try to handle that somehow, right? So let me actually create transition. Let's call it neighbors key, right? Neighbors key. Who's Neighborsky? Neighborsky. So, we wanna check if this thing is equal to undefined. If it's equal to undefined, we can safely just set this to the state. If it is defined, we probably want to double check. There should be two situations, when they're equal and when they're not equal. Right, when they're equal, we don't care, but what if they're not equal? Right, what if they're not equal? Which one do we pick? And this one is already interesting. Which one do we pick? What if we literally make it a new transition? That's a very interesting. So what that means, we are in that specific state, right? And we don't stay it in there, so we found another thing. We can make it a new transition. We can literally make it a new transition. So to actually make it a new transition, we can remove this branch. So that means this thing is not guaranteed to be stable though. Hey Todding, hope you're doing well. I heard the Duma wants to change some conscription laws. They've been doing that for a year already. I don't give a fuck. I'm gonna barricade myself with furniture. They're not gonna get me. Fuck them. I can sustain myself on oatmeal for half of a year. So, not going anywhere. Alright. So that should... So that means it's probably not gonna stay... But let's see. Let's see what it's gonna, how it's gonna behave. Right. So we constructed the automaton. Let's see how it looks like. Right. So I just want to print it and see what kind of transitions we have in there. Right. Are you still considered unfit under the new rules? Like nobody follows the rules. Right. So that's the thing about this country. Like there are some rules, but nobody fucking follows it. If they need like a lot of meat, they're gonna get it. And they don't give a shit about fitness and fitness. Okay, so let's take a look. Did it even compile Sadgi? It is Sadgi. It's a tiny bit a Sadgi. But it is what it is, and it isn't what it isn't. Is it not? I think it is. The missile knows where it is, because it knows where it isn't. Alright. So we're just waiting for the TypeScript compiler. Alright, let's see. Why nothing changed? Are we cached or something? Web. Alright, let's close this. I think it died. I think it literally died. Okay. So we got some shite. Console. There we go. Now we're freaking talking. I don't really know what the fuck is that. But this is array. Alright, this one is interesting. So there's a bunch of transitions in here. Here they are. Here are the transitions. Look at that. Alright. So here are the transitions. So do we have any other transitions in here? Yeah. This is the transition table. We've got the transition table for those things. Do we have situations when they're not? I think one of the things we have to do. All right. You know what I want to do? If this thing is already equal to itself. Not equal to undefined. Yeah. Console log. So if it's already, so that means we need to do I think for some reason my brain stops working, so I can't really comprehend whether this kind of situation will happen. Yeah, okay. So there are situations like this. Yeah, sometimes they may be like that. So if it's undefined, we define that, but if it's already exists, we're gonna ignore that. Sure. Okay, so let's try this. Did it... Does it clean everything when I refresh? This console behaves in a really weird way. Like I literally need to restart the whole page to get like a new fresh thing. It just like doesn't refresh. That's what I'm talking about. That's what I wanted to see. All right, so let's try to now get the next state, right? I kind of want to, you know, yeah, right, because we have some transitions. How it's going to play out? I can't really see anything. Doesn't seem to be changing at all, right? But it's staying. It is actually staying. So can we remove some of these things? I'm gonna start removing things and just see. And they're disappearing actually. Okay, so that's pretty cool. So, but they're not disappearing completely, right? It's actually so cool, right? Yeah, because they're disintegrating because of this kind of stuff, right? And it works like a flood fill in some sense. If you know what I mean. This is so cool. We need autoplay for this thing. We need autoplay. But the question is how can we do that? Right, so maybe we need to introduce another Lebatone. The being consumed mode, yes, yeah, exactly. But it kind of works as I expected, right? It kind of works as I expected. So let me see. So let's go to HTML, right? So and let's introduce a button, right? So ID play, right? And this is a Lebatone, and let's go into index.ts. So where's the next on load? Next, so let's copy paste this thing. I'm gonna quickly replace next. What is it called? Play. Okay. Next. Play add event listener. Play. There we go. And I suppose what we have to do, we have to set timeout, right? So we need to set some sort of a timeout. How can I use that? Where is the... so yeah. Let's give it a try. So this entire thing should have been like a separate function. Right. So next state. Right, so this is sort of like a next state. And what we're doing here, we're just doing this stuff in here. And on click, right, it doesn't really understand how to take the context. Null and assignable in a parameter. Can I just say something like this? Is that what you want? That's probably what it wants. So then later, I can do next state, right? Just like this. Right, and then I set timeout, next state, play play period. Right, so the question is, what is a play period? So it's in milliseconds, right? So it's milliseconds. Yeah, it is in milliseconds. So let's say it's 500 milliseconds, should be fine. But then it should reschedule this entire thing, right? It needs to reschedule. So there should be some sort of a function that is, you know, play iteration, right? It's some sort of a play iteration, which calls next state, but then does like reschedules play iteration one more time. All right, and we want to call play iteration right away. All right, so there's no way to stop this entire stuff, but that can be implemented later. All right, so did it compile? All right, so this is the next button, stuff like that. I keep pressing, nothing happens, and I press play. So it keeps basically computing the next one. So if now I can just do something like this, and okay, so it doesn't work. So it doesn't play. Yeah, okay, it doesn't play. I wonder why though. Because here it would do next state and set timeout play iteration. So maybe it's not set timeout. Oh, it's set interval. Okay. Is that what it is? Okay. What's the difference? I don't know. All right. So let's do play and a boom. All right. Why? Okay. So. Yeah. It's too fast. Why is it so fast? It should be in milliseconds. It is too fast. Doesn't refresh even. Okay. Set interval. Oh, set timeout is once. So that means set timeout was okay. Right, set timeout was okay. Oh, Jesus fucking Christ. I'm gonna close the chat. Nobody fucking knows. Okay. All right. So let's Google up set timeout. So what do we have? Sets the timer which executes function specified once time expires. Right, so it just does that once. So that means it should work periodically. Right. That means this entire thing should work periodically. So there's this problem. So this should work, right? Just by having a timeout in here, that should work. So I call it once, it calls the next state, and then it schedules the next. So, and keeps iterating. Makes sense to me? Makes sense to me. Right, so that means it's supposed to work initially. Chat is debating me yet again. Never listen to chat. Right. All right, but something doesn't really work, right? So it's supposed to like reiterate, but it doesn't do that. Okay, so yeah, now it works. Okay, so yeah, now it works exactly as expected, and it even works with precisely the interval that I expected. So let's actually do 250, right? What is this chat? Is this short for Chat GPT? I was thinking that you're gonna say, what is this chat? Is it in the same room with you? Right, so What's the chat you're constantly talking about, right? So, to be fair, streaming with chat feels like a schizophrenia simulator. Honestly, it's just like it's the voices in your head, right? Anyway, so let's actually try to play, and now this thing works. I think it should go a little bit faster, right? But you essentially, yeah, you essentially destroy all of these things, like so. That's pretty cool. The like the black outlines are actually very stable. Surprisingly, they're extremely stable. That's actually super cool. Huh. Very interesting. Yeah. If we can refresh it. So the most fragile ones are the ones that don't really have that many combinations. Right. And they keep disappearing. Right. Huh. Alright, it would be kind of cool to also build like assembling cellular automaton, right? The one that sort of like assembles the image back, right? So you would have to analyze it. I suppose you would have to analyze it in the order in which you want it to be able to replicate, right? So we can create a cellular automaton that actually, if you damage it, it should recover itself, right? It must recover itself. Right, it would be so interesting to explore all that. Unfortunately, I picked a very dumb technology stack, and I wasted so much time like troubleshooting problems that have nothing to do with cellular automatons. And what's funny is that that happens every time I do anything with web. It's just like every time I do anything with web, it's just like I have to troubleshoot some shit that has nothing to do with the problem I'm trying to solve, and it's just like a huge waste of time. The whole web is a huge waste of time. And imagine that this is like the main platform everyone develops everything for, and how much like human hours we're wasting every single second just by using this technology. It's fucking insane. Holy shit. So yeah, I think I'm gonna finish the stream in here. So maybe I'm gonna do another one where, like, because everything is established in here, alright, so the framework is working, so we're gonna continue like experimenting with this thing. But I already made too many episodes of this series, right? I have no idea how I'm gonna be marketing them on YouTube, right? No idea how I'm gonna be marketing, because none of that is particularly marketable, right? So what would I say to YouTube people? I've been sitting doing some web bullshit again for 3 hours. Please watch me. Here is the funny thumbnail. Is that what I'm gonna tell? Nobody's gonna fucking click on that. Nobody's give a shit. You've been struggling with web? Loser! Fucking show us the end product. Where is the end product? Nobody gives a shit about you struggling with this web shit. I have no idea how I'm gonna be marketing that. So yeah. So yeah. So just getting to the point where we could just have an image and turn it into a cellular automaton, some kind of cellular automaton, took way too much time than I expected. Way too much time. And web development is supposed to save you development time, right? Because look at all of these frameworks. I mean, I didn't reuse any of these frameworks, but I'm not sure if they will help me. So. I need more Starbucks coffee in you to do proper web dev, yeah. I don't know. I still don't understand how people like this shit. They probably never seen or tried anything else. Okay. Alright. That's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you the next time. See you next time. Love you.